we're going to do is,
We're
not putting the air on the machine right now. We're just going to go ahead and back the stop up. So that way when we give it a little air shock, it's going to pull the piston back. Is that on video? Got a pointer and a stainless steel scale on top.
Just the air pilot?
Yep, they're air pilot.
Are those two identical valves?
Yes, they are identical. This is your regulator and your water separator. And this is where your oil goes. And what happens is, as it's running, it will introduce a drop of water or drop of oil into this piston every so often. So in a moist air application, it's probably good to have that. The cylinders are lubricated for life, so you're looking at millions of cycles. But when you have water in your system, it will flush the lubrication out, so you've got to keep reintroducing the lubrication. So just a little bit of air tool oil, and just make sure this thing's filled up every once in a while. It's usually good to go. Okay, the piston is removed like this. Product cylinder comes off like that. Now this is a quad ring seal. You look at a cross section, it looks like a 4-leaf clover. You've got a valley in the center and on both sides and in the bottom. You've got 2 sealing surfaces as compared to 1 for an O-ring. And since they're actually a square design, they don't spiral twist. So you actually get a lot longer seal life with one of these. There's less seal squeeze, so there's less stiction in the piston sliding back and forth in the product cylinder.
The white film you're seeing there is a food grade grease.
That's right.
Even though you can taste this, you can see it's got
competitor, almost every single one of them, put a linear air cylinder on there with an arm on it, and they rotate it back.
Your timing mark?
Go.
I don't even have fittings on this one. Cap for the nozzle. This is your piston shaft with a spider. And the spider basically makes sure when your nozzle comes up and down, it keeps it centered so it doesn't deflect. The product flows around it a little smoother. But you have a double angle here. And that's the bottom.
A straight tube that basically works as putting a thumb over a straw. When you draw it from the milk stays in the straws. That's capillary action. So all we're doing is coming down over the top of this and sealing the top of the straw, which is the thumb over the straw. The tube itself is completely straight through. And for certain thick liquids, this is yours, this may work very well with no dripping.
Excuse me 1 second. It's a pretty good guess, 107.5. Could actually use a smaller nozzle. Consistency is the key.
And this is with an orifice, how big?
I will have to measure it.
But it's a much smaller one than we had before.
Yes.
And how consistent are they?
97.5, 98, 98. What type of cutoff do you call that, your terminology?
This is a bevel seat.
A bevel seat cutoff valve at the foot of the dispenser.
And we're running a consistent
It
98.
just functions the opposite of what we've been testing. Okay? The piston actually comes out and the product rolls around the piston, but they cut off really nice and clean. So we just make these a standard size, but you can make them whatever size you want.
So this is the inverted cone.
This is the inverted cone.
Okay.
Maker.
That's an answer. Here it is. Well, because we have the eyeball thing in process of the code to try to fly it over the internet.
Yes. This is a 2090-2 tandem filler. This is actually for pumping peanut butter, and we're just in the trial stages of it now. We've actually set this up with the hoses and recirculated it back into the hopper. This thing is run for 24 hours straight with no seal changes. We haven't disassembled anything, we just covered it up at the end of each run. But I believe there was like 20,000 cycles in these 3 days pumping peanut butter. And there's no seal failures or anything like that.
You would expect that.
Yes, which is what we expect.